This is Dr. Jansen, and today we're going to solve a quadratic equation using square roots. So let's get started. So looking at our first equation here, number one, we're solving for x. So in order to do that, we need to isolate our variable and get it alone. So first we see that this x is connected to 4 by multiplication. It has this x squared, and also on this left side of the equation we see this minus 64 hanging out over here. So these are all the things we need to get rid of in order to get x alone and solve for x. So the first thing that's easiest to get rid of right here is this minus 64, because actually when we're isolating variables we do the order of operations backwards. So I know it sounds kind of weird, but so we think of PEMDAS, and so actually we're starting with addition subtraction at the end. So we're going to undo addition subtraction, and so the opposite of subtraction is addition. Do our inverse operation, and that will get that to cancel. And if we do something to the left side of our equation, we have to also do it to the right side of our equation to balance our equation out. And now we're going to rewrite what's left of our equation. So we have our 4x squared. These, again, completely canceled, so we're not going to write anything. Copy down our equal sign, and then 0 plus 64 left us with 64. Next, okay, again, also continuing to move backwards through PEMDAS. We don't have any more addition, subtraction, and undo on this side, but we do have some multiplication or division in the form of 4 and x are connected by multiplication. Well, what's the opposite of multiplication? Again, using those inverse operations to get rid of things. Opposite of multiplication is division. So we're going to divide by 4. If we do something to the left side, again, we have to do it to the right. So 4 divided by 4 gives us 1. We don't need to write 1 in front of the x, so we just write x squared. 64 divided by 4 is 16. So we're left with x squared equals 16. Okay, so now we need to reduce x squared. The opposite of squaring something or raising something to the second power is actually square rooting something. So if we do that, that'll actually cancel out our x squared. But again, if we do something to the left, have to do it to the right. So we're left with x equals whatever the square root of 16 is. Now, a lot of us probably know that the square root of 16 is 4. If you didn't, you could have punched that in your calculator. But what we need to be careful of here is when we remove that 4 from the square root, we're actually not only removing a positive 4, but a negative 4 as well. So it's actually positive and negative 4 is our answer here. And so when we go to write our final answer, we're going to write our fancy braces. Yours don't have to be beautiful. Mine are not beautiful either. And we always write our answers in order from least to greatest. So I'm going to put my negative 4 first, followed by my positive 4. And that is my answer. Great job. All right, now let's move on to our second problem over here. Whoops. Okay, let's move on to our second problem. It looks a little simpler, because it is, actually. We've got x squared minus 5 equals 0 right here. And we're going to solve it the exact same way. We're just trying to isolate x, just like we did before. And here we have x squared minus 5 equals 0. So same thing, we have x squared, and then also hanging out over here with x, we have a minus 5. So same process we followed before, following the order of operations backwards to isolate x. We're going to first undo minus 5. The inverse operation, or the opposite of minus 5, is adding 5. We have to do that to both sides to keep our equation balanced. And that leaves us with x squared equals 5, because those canceled out there in the middle. And remember, we just learned that the opposite of squared is square root. So we're going to do that to both sides. And I get x equals positive and negative square root of 5. And right now, you're probably wondering, Dr. Jansen, but why didn't you take that 5 out of the square root? Well, because, my friends, like over here in our problem where we had our beautiful 16, if you put that 16 in your calculator, it comes out to be that 4 that comes out beautifully from within that square root of 16. But 5 doesn't do that. 5 is what we call an irrational answer. If you put this square root of 5 in your calculator, you can go ahead and do it right now, it comes out to be a really crazy number. That's actually why we call it irrational, because it's not rational. It's crazy. And so we want to keep it inside of that square root. Because unless it comes out to be a beautiful number, unless it's a perfect square, is what we call that, like our 16s or 25 or 36, unless it comes out to be like a beautiful number, we do not want to take it out of our square root like this 4 ended up being. We want to leave it inside of our square root. It still comes out to be positive and negative, but we want to leave it inside. And it looks much nicer that way, and it stays much neater that way in our answer. And so our final answer here is actually going to come out to be still in our fancy brackets, still in order from least to greatest, but it is going to look just like that. And we call that an irrational answer, and that is totally okay to get. Great job.